Welcome to another session of learning expansions. I hope you all enjoyed and learned from the previous session, that is expansion of basics. Now let's move on to the next part, that is expansion using identities. As I told you, this expansion can be modeled as the area of a rectangle in the previous case, but for this you would see that since it's a plus b the whole square, it is nothing but a square since both the sides are equal. So this becomes a plus b and this becomes a plus b. And when you expand this, you would get the formula a squared plus 2ab plus b squared. A common error is normally students forget to write 2ab. Don't do it. So it is a square plus 2ab plus b square. The second one would be the area of a square whose sides are a minus b and a minus b. So if you expand this, it's going to be a squared minus 2ab plus b squared. And this one, when you expand, you will see that the AB and AB terms get cancelled and you'll end up with only a squared minus b squared. So I hope you recall these and ensure that you really know these identities before we go to this expansion. If you don't remember these identities, you can go back to the normal and do it by distributive property. But this is another way of expanding. So let's look at this question. Expand the following 2x plus 3y the whole square. So let's recall the identity. This is of the form a plus b the whole square is equal to a squared plus 2ab plus b squared. So you would see that this is a and this is b. So I would just apply the formula a squared. But my a is 2x here, so it becomes 2x the whole squared plus, this is a constant 2, my a is 2x, so that's your a, and the b is 3y. So into 3y plus 3y the whole square. So basically this, when you expand, is 2x multiplied by 2x. So this becomes 4x squared. Alright, so this is 4x squared plus 2 multiplied by 2 is 4 and this becomes 12xy and this would be 3y multiplied by 3y, which is 9y squared. And there you go. We have expanded this easily by using the identity formula. Right? So this is of the form a plus b the whole squared. Now let's look at another example. And this x minus 5y the whole square. This can be modeled to this identity a minus b the whole squared is equal to a squared minus 2ab plus b squared. So this would be a and this would be your b. So let's apply this and I would get a squared. So this becomes x squared minus 2, a is x, b is 5y. Okay, the minus is already here. So if you just take the positive 5y, it's enough, plus 5y the whole square. So now let's simplify. X squared minus 10xy plus 5y into 5y is 25y squared. And your simplification stops here because we do not have any like terms. Hope this is quite clear to you all. And now let's do the next type, 3x minus 5. So this is of the format a minus b multiplied by a plus b, which would give you a squared minus b squared. So this is basically a, this is b, this is a, this is b. So if I have to use the formula, it is 3x the whole squared minus b. b is 5, so minus 5 the whole squared, which is 9x squared minus 25. Easy, right? So, if you know logically how to apply it, it becomes pretty simple. Alright? Now, let's look at this second. Yeah, slowly the difficulty level is increasing. So we look at this and we see that we could identify this as a minus b the whole squared, right? So a minus b the whole squared is a squared minus 2ab plus b squared. So let's identify what is our a and what's our b. So you will see that a is 4 by 5 and b is 1/3. So let's replace in the formula a squared, but your a is 4 by 5, so it's 4 by 5 t the whole squared minus 2 multiplied by 4 by 5 t, and b is 1/3, plus you will get 1 by 3 the whole square. So this is nothing but 4 by 5 multiplied by 4 by 5 t. So 4 into 4 is 16, 5 into 5 is 25, t squared minus, so here you have 2 into 4, 8t, and the denominator is 5 into 3, which is 15, and this becomes 1/3 multiplied by 1/3, which is 1 by 9. So you need to know a little bit of multiplication of fractions, and it is the same thing when you apply for expansions, right? So the difficulty level slightly increases from integers. So here you see you have integers and slowly it becomes into fractions, all right? So let's look at the last one. Yes. So you see here, basically the difficulty level has slowly increased. So here you will see that this is a plus b the whole squared. This would be a minus b the whole square. So let's do it very systematically. So this would become a plus b the whole squared is a squared, 3a the whole squared plus 2 into 3a multiplied by 4b plus 4b the whole squared minus. It's a good practice that after minus you apply a bracket. Okay, so this becomes 3a the whole squared, which will be minus 2ab. So 2 times 3a into 4b plus 4b the whole square, right? Close the bracket, minus 48ab, right? Minus 48ab. Okay, so now what happens is, let's expand this. So this becomes 9a squared plus 2 times 3, 6, 24ab plus 16b squared minus 9a squared minus, this becomes 2 into 3, 6, 24ab plus 16b squared minus 48ab. Now there are certain terms which will cancel or become 0. So you'll see 9a squared, and this is minus 9a squared. It gets cancelled. 24ab, but minus time minus is positive, so it will not get cancelled, whereas 16b squared and minus 16b squared will get cancelled. Now let's look at the other two terms. So this will be 24ab. This will be minus time minus, which is 24ab minus 48ab. Alright, so this becomes 24 plus 24 is 48ab, and 48ab also gets cancelled, and you would get the answer to be 0. Alright, so basically it, if you know the identity, it's pretty simple. You just follow logically and get your expansion done. Hopefully you have understood this part of identities, and let's go move on to the next type of identities in the next session. So stay tuned, and you may also want to try these questions from your textbook or worksheets, whatever your teacher has given, so that you would see that expansion is really, really easy if you follow the steps meticulously. Thank you, and please do subscribe for watching this channel. Thank you very much.